Welcome, everyone. Today we are diving into a groundbreaking development in AI called S1 DeepResearch. As you can see right from the start, the goal here isn't just about building another search tool. This is about moving beyond simple search and moving toward real-world, long-horizon research agents that can ingest data, extract knowledge, and generate hypotheses. To understand why this is so important, we first have to acknowledge a hard truth: the traditional search paradigm has peaked. Locating basic information is a solved problem. The new frontier is moving from extractive search, where a query simply points to a single fact, to constructive exploration. S1 is designed for open-ended goals, allowing it to use multi-hop reasoning, resolve conflicting evidence, and synthesize complex deliverables. So, how does S1 compare to what's already out there? Let's look at the DeepResearch capability matrix. Most existing models are still stuck in that search-centric mindset. S1 DeepResearch, however, is built on a unified foundation that successfully covers all 6 pillars of real-world research. Whether it's long-horizon text reasoning, multimodal capabilities, strict instruction following, or dynamic skills, S1 checks every single box. Real-world research is incredibly complex and generally relies on 5 distinct dimensions: complex reasoning, report writing, instruction following, file understanding, and skills usage. What makes S1 truly remarkable is that it internalizes all of these diverse behaviors into a single, highly efficient 32 billion parameter model. How did they train such a capable model? Through a rigorous agentic data construction system designed to synthesize 15,000 high-quality trajectories. They achieved this by combining the verifiability of closed-ended Q&A with the realism of open-ended exploration across 3 distinct phases: task formulation, agent loop execution, and multidimensional verification. Let's break down that first phase: graph-grounded task formulation. The creators didn't just guess what tasks the AI should practice, they built them structurally. By leveraging dense knowledge subgraphs from Wikipedia and web searches, they injected strict constraints, like format, objective, and scale, to generate highly specific and challenging research prompts. But they didn't stop there. They applied topology-aware difficulty filtering to ensure the model wasn't wasting time on easy questions. They intentionally discarded simple parametric knowledge tasks and retained only the top 30% most complex tasks. This means the model was trained strictly on tasks requiring true multi-hop exploration, deep dependency chains, and parallel reasoning branches. Phase 2 is where the magic happens: the agent loop sandbox. Here, those filtered tasks are rolled out into a fully executable environment. The agent dynamically interacts with a variety of tools like academic search, code execution, image QA, and bash shells. It observes feedback and constantly self-corrects, perfectly capturing the exact trajectory of human-like research. Finally, Phase 3 is multidimensional verification. Final outputs are subjected to incredibly strict filtering. If a trajectory violates a constraint or hallucinates a citation, it is completely discarded. Only the trajectories that are verifiable and meet rigorous academic standards are allowed to survive this phase. The ultimate result of this pipeline is the S1 DeepResearch 15K dataset. Out of nearly 50,000 initial trajectories, they distilled exactly 15,000 high-quality agentic trajectories. This represents a massive shift in AI training data, moving away from simple knowledge synthesis and heavily dedicating nearly 65% of the data to complex reasoning and deep execution. If we look closely at the anatomy of a research trajectory, the difference is night and day. A typical search agent often gets trapped in verification loops, endlessly calling tools with very little actual synthesis or deep thinking. S1 DeepResearch, on the other hand, knows exactly when to stop searching. It excels at strategic, deep step-level decision-making and is optimized for producing massive, structured deliverables. When it comes to performance, S1 is a true heavyweight champion wrapped in a lightweight architecture. The 32 billion parameter S1 model punches far above its weight class. As you can see, it matches the DeepResearch performance of massive 300 billion to 1 trillion parameter frontier models, operating with up to 30 times greater parameter efficiency. This is clearly visible on the state-of-the-art DeepResearch index. Averaging across 18 different evaluations, S1 DeepResearch scored a 55.2. It completely dominates open-source models of a comparable scale, like the Qwen 3-32b, which scored 35.2, and it directly challenges large proprietary systems from competitors. One of S1's standout features is its mastery of 9-dimensional constraints. Because real research requires adhering to overlapping rules, S1's agentic training resulted in a massive 6x improvement in strict instruction following. On the DeepResearch IF benchmark, it leapt from a base score of 4.1 all the way up to 25.2. Furthermore, S1 thrives on test-time compute scaling. By giving the model additional sampling rollouts, it can explore diverse retrieval paths and easily recover from suboptimal intermediate decisions. For example, on the Xbench DeepSearch evaluation, moving from a single pass to 3 passes unlocked a massive performance ceiling, jumping the score from 79.3 to an incredible 93.0. In conclusion, the overarching takeaway is that trajectory quality dictates agent capability. S1 proves that simply scaling up a model's size isn't the only path to advanced AI. By utilizing high-complexity, verifiable trajectory data, we can unlock true deep research in much more accessible models. And the best part? Both the S1 DeepResearch 32B model and the 15K dataset have been fully open-sourced to the community.